Let's think about exponential graphs first. The easiest exponential graph is y equals to 2 to the x. You can think about this graph by first making a table, x and y. Let's pick x as negative 2, negative 1, 0, 1, and 2. And then we just have to plug in these values into this function to produce the y value. So first, negative 2 goes here. So the y value will be 2 to the negative 2. And as you know, negative power means 1 over. And then it will be 1 over 4. That's about 0.25. Negative 1, if you plug in, that's 2 to the negative 1. That's 1 over 2, which is 0.5. When you plug in 0, you get 2 to the 0th power. Anything to the 0th power is 1. Then you get 2 to the first power, which is 2. 2 squared equal to 4. So these are the values. You plot them on the xy plane, and that's how you get the graph. So let's say here's negative 1, here's negative 2, positive 1, positive 2, 1, 2, 3, all the way there. It'll be 4. And let's plot them. First, negative 2, 1 4. So this is 1/2, that's 1 4. So it'll be right here. Negative 1, 0.5 is here. 0, 1, 1, 2, and then finally 2, 4. So you plot all these points, negative 2, 0.25, negative 1, 0.5, 0, 1, 1, 2, 2, 4. That's why we plotted. Connect them, and then the end result is you have this kind of graph, and as you can see that as you go further to the left side, it gets closer and closer to the x-axis. In other words, this will be your horizontal asymptote. Asymptote means it's something that the graph gets closer and closer to. So the graph gets closer and closer to that asymptote. Now, you can do this in general, and you're going to see that as long as your graph looks like y equals to a to the x with a bigger than 1, you're going to get the graph of this form. Now, whether a is big or small, that's going to control the steepness of this graph. So for example, if you had like y equals to 10 to the x, they'll increase very fast like that. On the other hand, if you have y equals to 1.1x, that's going to increase gradually, so it's like flatter than the other one. Now, the reason I stated that this should be bigger than 1 is because if it was 1, then 1 to the x power. What's 1 to the x power? That's always 1, regardless of the value of x. So in this case, you just get a flat horizontal line. So it's different from this. Okay. Now let me try to graph y equals 2 to the negative, no, 1/2 to the x. Because this time I want to consider this graph with this value not greater than 1 but less than 1. What will happen? Now I could also make a table for this and draw the graph in that way, but let me take another approach, which is to use transformations. So the first thing I want to do is to rewrite this 1/2 as 2 to the negative 1 power. Negative 1 gives you the reciprocal, right? And then you have to multiply them, you get 2 to the negative x. So you have this graph, y equals 2 to the negative x, and that looks awfully similar to this one. The only difference being that x is replaced by negative x. Now recall when we did the reflections, that when you have x, negative x, y, negative y, the one that goes from negative x to x flips over the y-axis, right? So the effect that this negative has on this graph is that this graph will be flipped over the y-axis, and the resulting graph will be like here. Okay. The y-intercept will still be 1 as before, and then the horizontal asymptote will still be at x equal to 0, and the graph actually goes down instead of going up. Okay? And you can kind of see that this is going to happen for any a to the x, as long as your a value is between 0 to 1. So the graph will look like here. And since when you plug in 0, you get 1, so all of these will have the y-intercept as 1. What about a equal to 0? Well, again, 0 to any power is 0, so you get some horizontal line up. But except that when you have 0 to negative power, then you have 1 over 0. That's undefined. So things get really complicated once you are not in one of these two examples. So what you need to, we're only going to consider this. When you have a as negative, then that gives you, so say a as negative 1 to the x. This is not good as a function because, for example, if you had x value as 1/2, that's same as square root of negative 1. That's not a real value. And we only consider real values in pre-calculus. We only consider functions that give out real values. And this one will, so if you had a function that's like f of x equals to negative 1 to the x power, that's not a function that gives out real values, so we don't consider that. So we only consider y equals to a to the x type where a value is either bigger than 1 or between 0 to 1, and the graphs are either this one or that one. So to summarize, if a is bigger than 1, then the graph will be increasing. If a is between 0 to 1, then as higher the x value goes, the value will decrease.